Okay. Yeah. So, hi everybody. I'm Chris. I promise I won't be looking at my computer the entire time. Yeah. That's pretty cool. Let's make things cool. Where's my mouse? So, just to, yeah, okay. So I can type into this one. There we go. Yeah. Sorry for the delays. Technical things. Okay, so can everybody read that? I blew up the font really big. So this is the portion that is demos, and I'm going to do some slides. And they might be a little bit redundant. But this portion is just to prove that things do sort of work. I'm not some confidence man trying to get Portland to build monorails or something. Though that would be cool. Okay, so yeah. So let's clone 127 1 voxel. Oh, louder? Oh, okay. Sorry. Okay, so everyone's familiar with Git cloning. I just finished up some stuff last night that actually would let me do this demo stuff. I wasn't hugely expecting to do it, but you can see we just used Git to clone voxel engine. Yay! It turns out that the server I'm cloning from is actually running in pure node. It's generating the pack file. It's doing all the conversation stuff. So that's cool. And the other one is, oh man, that's going to be hard to see. Again, voxel engine. Hopefully that's typed correctly. Oh, awesome. Thanks, Raythan. Sweet. So yeah, it clones in the browser too, using Browserify. And there's Max Ogden's avatar. So, hi Max. Okay, cool. Presentation time. Just wanted to make sure that everything was cool there. Okay, so JavaScript or Git in JavaScript. My name is Chris. I work at Urban Airship, and as aforementioned, I really do like it. I promise. We're hiring. It's fun. Both the working there and the hiring. So really quick, I'm going to breeze through these slides. The first thing is why. So in 2010, for a Django Dash, I built a site with a friend called Repocracy, which all it would do is you give it a public Git URL and it would turn it into a Mercurial repository, and vice versa. It was nearly immediately trolled. It looked like this. I spent hours laboring over the illustration. Somebody just put Linux in there. That turns out to blow up rack-space servers that are 256 megabytes of memory. Who knew? So the outside of this journey, I just wanted to limit repo size before cloning. So I wrote something called Tempest Fusion. It was bad. It was horrible. If you open up the code base for it, bats will fly out at you and probably suck your blood. There was no zlib in Node yet, so there was just unlicensed inflates floating around the web. The Wild West, basically. It was heavily tied to the file system API. It was monolithic, and of course, it was 3 years ago, and I didn't know what I was doing. So, yeah, feel my pain. About 2 or 3 months ago, JSGit was funded, and I wanted to back with code and also apply some lessons learned from contributing to Voxel.js, and I think that worked out pretty well for this. First of all, quick show of hands. How many of you are experienced or have knowledge of the internals of Git? Whoa, awesome. Good job, guys. I'm going to breeze then. Yeah, awesome. So Git is basically one thing overall. It's a content addressable key value store. So what that means is from any content, you can get a key, and the key is those lovely hashes that you see all over the place. And the hash is formed by just taking the SHA-1 of the contents of that object. And there's only 4 types of objects. There's tags, which arbitrarily tag a given other object. So tags aren't just limited to commits. You can also tag a blob or tag a tree. if you were mean, I guess. Commits and trees and blobs. And we'll just kind of run through these. That's what a tag looks like. Commits may have a tree and may have a parent or more, or several parents. They should have an author and a committer and a message. And the parent just points to the next commit. The tree actually points to the next object, which is trees. Each directory is listed in this form. Like, there's the Unix permissions, there's the actual hash of the object that it's pointing at for that directory entry, and then the name of it. And then blobs are just their content. So like when you have a file, it's just the hash is just of its content. It doesn't know about its file name. So Git is also two object stores, usually. The Git we usually think of. It's just loose and pack files. Loose is just in your git.get objects directory with the first two characters of the ID, and the 38 res is in that directory. And it's just deflated data, basically. Importantly, Git doesn't store diffs, at all. It just shows that to you because that's what humans like to take in. The pack files, there are two files. There's a pack file, and then there's an index file, which allows random access into the pack file. The pack file has many objects. We'll talk about pack files in just a second, but this is generally where the computer science lives. This is where you get binary searches and fan-out tables and mmap and all sorts of fun things. Algorithms. This is what it looks like in JavaScript right now. There's two repos, git walkrefs, which is kind of like git log. It's graph walking, basically, as a stream. And repo, which you can just give a directory. It opens up if it doesn't get an error. You give it all the refs, all the hashes that you want, and you just kind of log git find hashes. So, remember what I was talking about pack files? Here's a pack file. It starts with a 4-byte magic number, pack, 4 bytes of version. There are two versions, 1 and 2. There are 4 bytes of number of objects, and then objects. So an object header looks like a 1-bit continuation, 3-bit object type, and that actually allows you to have 7 values instead of the 4. And then 4 plus n bits. The size is actually bar int encoded, and you take that 4 bits, and you keep going until the high bit isn't set. And then you just take those 7 bits, and you get a number. Importantly, this is the uncompressed size, not the compressed size. It's followed by the compressed object data, so you don't know when to stop. This is a problem if you're using Node zlib, because it won't give you back the unused bytes. They're just gone. At the end of it, a 20-byte checksum. And that's just all the contents of a pack file. So there's two other types that are secretly in pack files, and they hang out there. The offset and reference delta. And those are x delta diffs of objects. The only difference between them is reference actually has a full reference. It can reference something that hasn't happened yet in the pack file. It can reference something outside of the pack file. Offset is a negative offset from the current object, and you just look up that object and reinflate it and apply the diff to it. There's only a certain maximum number, a configurable maximum number of deltas referencing deltas, because that would take a long time to decompress any objects. The packing heuristics are super neat, as I mentioned here. They're super optional. You don't have to do them, and right now I'm not doing them because I'm horribly lazy. And the docs for those are basically just an IRC log of people asking Linus how it works and him responding, magic. So that's sort of what it looks like now. If you can kind of read, I'm requiring file system git list pack. Importantly, to actually get the key from a object in a pack, you have to reinflate it and turn it into an object, and then run SHA-1 over it. So to actually create you're expected to create the index yourself. So you run over it, pipe it through list, pipe it through Objectify. List gives you sort of raw-ish objects, which includes the reference deltas and offset deltas. So they're not usable yet. Then you give it Objectify with a find function, so just in case the reference delta finds something in another pack, you can still apply it and get the object out. And you can add a data listener and keep around, keep al store. And similar, so this is actually the fetch pack protocol. You give it a URL, you give it a function that can say what it wants from the advertised refs, and then you pipe it to a transport with a connection, which in this case is just TCP, and then you pipe it back to the client. So it basically talks to itself. It's basically one Git client yelling at another Git server and yelling back to itself until they reach an agreement. And then there's a little tiny sideband stream called client.pack, which is actually the pack file that gets sent down. You pipe it through List, pipe it through Objectify, pipe it into your favorite key value store. It works great with Redis or React or Level.js, which is what we're using in the browser, which is on top of IndexedDB. So this is what it looks like in the browser. I use shoe.connect. It's sort of a fib. I had to like base64 encode the data because shoe is a text stream, not a binary stream, but pretend. But basically you can swap out the connection and swap out where you're putting stuff and things just work. So some lessons learned, real quick. Write lots of small modules. Like this is going to come up later in this conference, so I won't belabor it too much. But there's like 30 or 40 Git modules that I've written and others of which I've written. And you'll notice some of them pop up a couple of times. It just happens that like I was npm LSing two different things. Yeah, there are so many advantages, which are enumerated here. It's easier to test them, easier to write them, easier to document them, and easier to change them later. Also, use Browserify. It helps out a lot because you can write your code like it's just Node code, and we like Node code. So it's a great build tool in and of itself, even if you're not using any specific Node stuff. The ability to shim out specific modules using the browser directive is incredibly awesome. Thanks. And it's got great tooling. Source maps landed in it. I'm tooting my own horn with Beefy. I like Beefy. It's basically just a server that browserifies stuff when you request it. So you don't watch, you just request. TestLink CI. And they all work together really well. This one, I'm a little nervous about suggesting this one, but where it makes sense, put things in terms of streams, because streams are a nice pluggable API that you can like shim out the bits that you don't need or don't have yet, which is really important in the case of Git because it would be really hard to go from 0 to full working Git. So streams are nice. You don't need all the data it wants to process, which is really important in the case of running it in the browser because we're running Inflate in the browser, so we had to like, right now it doesn't go into a web worker, but it should in the future. But that's a really CPU intensive thing. I'm using min streams underneath, mostly because the primary JSGit founder, CreationX, really likes min streams, but it's easy enough to like put through on top of them and just have like a happy API for everyone involved. And I think I've got one more thing if I've got a second. Do I have 1 second or? No questions. Okay, cool. Oh, yeah, okay. If you have any questions or anything, talk to me. I'll usually be back there. JSGit on Freenode, Isn't It Vacant on Twitter, and Chris Dickinson on GitHub. So, thanks.